Coming to third sum, the 4-digit numeral 3a1 is divisible by 9. What does a represent? To answer this question, we need to know the divisibility rule of 9. What is the divisibility rule of 9? Divisibility rule of 9. If the sum of digits of a number is divisible by 9, then the number will be divisible by 9. Divisibility rule of 9. If the sum of digits of a number is divisible by 9, then the number will be divisible by 9. This is the divisibility rule of 9. I want to apply this rule here to answer this question. The 4-digit numeral 3a1 is given. Now we need to find out the value of a. According to the divisibility rule of 9, the sum of digits of this number should be divisible by 9. That means 3 plus a plus 1 should be divisible by 9. 3 plus 1 means 4, a plus a means 2a. It should be divisible by 9. That means it may be equals to 0, or it may be equals to 9, it may be equals to 18, maybe equals to 27, etc. First equate it, because these are all multiples of 9 and these are all divisible by 9, so it may be equals to these numbers. You need to observe this. If we equate this to 0, then 2a will be, if 4 plus 2a is equals to 0, then 2a is equals to minus 4. Our digit a should not be in negative, so 0 is failed here. Now equate to 9. 4 plus 2a is equals to 9, then 2a is equals to 5, a is equals to 5 divided by 2. Our digit a should not be a fraction, so 9 is failed here. Now coming to 18, 4 plus 2a is equals to 18, then 2a is equals to 18 minus 4, that means 14. If 2a is equals to 14, then a is equals to 14 divided by 2, that means 7. Here a is equals to 7. We found the answer, a is equals to 7. But if you, I think you have a doubt, if you take 27, what will be the answer? So 4 plus 2a is equals to 27, equate it. Then 2a is equals to 27 minus 4, that means 23. Here a is equals to 23 by 2. Our a should not be a fraction. Then the another number is 36. Take 36. 4 plus 2a is equals to 36. Then 2a is equals to 36 minus 4. That means 32. Then your a is 32 divided by 2, that means 16. A should be a single digit. We should not take 16 here. So this also fails. So ultimately our answer is 7. Okay. It is the process. Next, coming to the fourth sum. Find the sum. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 plus 1 over 5 times 6. It's very simple question. 1 minus 1 by 6 is your answer. That means 5 by 6 is your answer. The logic here is 1 over 1 over 1 times 2 can be written as 1 minus 1 by 2 plus 1 over 2 times 3 can be written as 1 over 2 minus 1 over 3. Take its LCM. 2 times 3 is LCM. 3 minus 2, then 1 over 2 times 3 is your answer. Then 1 over 3 times 4 can be written as 1 over 3 minus 1 over 4. 1 over 5 times 4, 4 times 5 can be written as 1 over 4 minus 1 over 5. 1 over 5 times 6 can be written as 1 over 5 minus 1 over 6. You can cancel minus 1 by 2 and plus 1 by 2. Minus 1 by 3 and plus 1 by 3. Minus 1 by 4 plus 1 by 4. Minus 1 by 5 and plus 1 by 5. The answer will be 1 minus 1 by 6. It means 5 by 6 is your answer. Just calculate it. Is right or wrong? 1 by 2 minus 1 by 3 is equals to 2 times 3 is your LCM. Then 3 minus 2 is your numerator. Then 1 over 2 times 3. So 1 over 2 times 3 can be written as 1 over 2 minus 1 over 3. It's a simple logic. You can find out any of this sum. 1 over 2 times 3 plus 1 over 3 times 4 plus up to 1 over 98 times 99. It's very simple. 1 over 2 minus 1 over 99. Simplify this. It's your answer. This is the logic behind this sum. Now, the last and final sum for today's class. The fifth sum is, if we count by threes starting with 1, the following sequence is obtained. What's the sequence? 1, 4, 7, 10, etc. What is the 100th number in the sequence? What is the 100th number in the sequence? Just observe here. 1, 4, 7, 10. It's a pattern. We need to observe a pattern for this sum. 1. 1 can be written as 0 plus 1. 4 can be written as 3 plus 1. 7 can be written as 6 plus 1. 10 can be written as 9 plus 1. Why I am writing like this? Because 0, 3, 6, 9, all these are multiples of 3. Simply I can do it by 3 times sum n plus 1. Here n may be 0, then 0 plus 1 you get. Here if you put n is 1, then you get 3 plus 1. If you put n is 2, then you get 6 plus 1. If you get n is 3, if you put n is 3, then you get 9 plus 1. So here n starting from 0, 1, 2, 3, etc. Here the question is 100th. We need to find out the 100th number. That means "99" will be your 100th number. You need to count from 0, 1, 2, 3, 4. What is the fourth term? 3 here. What is the third term? 2 here. So what is the 100th term? 99 here. So put 99 in place of n. 100th number. Put n is equals to 99. So 3 times 99 plus 1 will be your answer. 3 times 99 is 297 plus 1. So 298 is your answer. So these are the sums here. Try to observe the procedure. Procedure is very much important. The best procedure will complete the sum in less time accurately. We can continue in the next class. Thank you.